Hi everyone, in this video I am going to explain you about the Avogaro number and mole concepts in chemical equation in stoichiometry. The learning objectives of this video is perform the stoichiometry calculation involving number of Avogaro and moles, and I am going to explain details of what stoichiometry and what information can we be obtained from the balanced chemical equation, what is the Avogaro number and mole, and what is their relationship. Now let me move to the first concept, that is, what is stoichiometry? The stoichiometry is the study of quantitative composition and the relationship that exists between the reactants and the products, and it is easier to calculate the amount of unknown substances from the given other substance in a particular chemical reaction. The stoichiometric ratio calculation always comes from the balanced chemical equation. Not always remember to use the balanced chemical equation to calculate the stoichiometric problems. If the given chemical reaction is not balanced, so try to balance the given chemical reaction first and then perform the stoichiometric calculation. Another thing is information obtained from the balanced chemical equation. In the previous video, we have seen that to balance chemical equation, we will use the coefficients, and these coefficients are very important in stoichiometric calculation. These coefficients in a stoichiometric equation, the coefficients of reactants and the products represent their stoichiometric amount and give information regarding the proportionality of these amounts of substance involved in the reaction. And let me explain this with example. If you see this chemical reaction, in this chemical reaction, the first two is coefficient and this one is the subscript. This coefficient 2 indicates the number of molecules and this subscript 2 indicates the number of atoms, and the interpretation will be, for this chemical reaction, we can say that two molecules of hydrogen will react with 1 molecule of oxygen to produce 2 molecules of water, or we can say that 2 mole of hydrogen react with 1 mole of oxygen to produce 2 moles of the water. This is the one example. Another example is if we consider the reaction between the nitrogen and the hydrogen to produce ammonia. In this chemical reaction, we can interpret this chemical reaction in terms of molecular, in terms of molar, and in terms of mass. The molecular interpretation is, in this chemical reaction, 1 molecule of nitrogen react with 3 molecules of hydrogen to produce 2 molecules of ammonia, and the molar interpretation is 1 mole of nitrogen react with 3 mole of hydrogen to produce 2 mole of ammonia. And similarly, for mass interpretation, we can say that the molecular mass of this 28 grams of nitrogen will react with 3 times its molecular mass of hydrogen to produce 2 times of the molecular mass of the ammonia. This is the second example. The third example is the reaction of propane with oxygen to produce carbon dioxide and water. In this chemical reaction, and after checking the balanced chemical reaction is balanced or not, we can say that 1 mole of propane reacts with 5 mole of oxygen. Or in another way, 1 mole of propane is stoichiometrically equivalent to 5 mole of the oxygen, or relating the propane with the product, 1 mole of propane will produce 3 mole of carbon dioxide, or 1 mole of propane is stoichiometrically equivalent to 3 mole of the carbon dioxide, and you can say similarly for that of the water produced. This is all about what stoichiometry and what information can we obtain from the balanced chemical equation. Another thing is the Avogaro and the mole concept. In the Avogaro and mole concept, before going to explain what Avogaro number, let me explain the concepts in terms of vocabulary of days and dozen, gross and rem and trillion. In terms of vocabulary of day, we know that in a week there are some days, in one fortnight there are 15 days, in 1 month there are 30 days, and again in 1 year there are 365 days and 12 months. Similarly, in 1 century there are 100 years and the like. This is the vocabulary of days. And in the dozen, gross and rem, we can say that 1 gross means it contains 144 particles. In this case, pencils, and 1 rims is equal to 500 particles. That is, in this case, 500 sheets, and 1 dozen is equivalent to 12 particles. In this case, there are 12 eggs. This is one concept about regarding the Avogaro. Similarly, 1 trillion means that 1 times 10 raised to 12. In this way, similarly, the Avogaro number is a number which is 6.022 times 10 raised to positive 23, not negative 23. One misconception is most students put this as the negative 23, but not negative, it's positive. And this is equivalent to this number. And one more is equivalent to 6.022 times 10 raised to positive 23 particles. These particles may be atoms, molecules, formula, and so on. And this is the concept of the Avogaro. When I go to the concept of the definition of mole, mole can be defined as it is a standard number of particles, maybe atoms, ions, molecules, or formula units. Or in another way, mole can be defined as the amount of substance that contains the same number of particles as the atoms in exactly 12 grams of carbon 12. And its unit is moles or moles. So this is the definition of the mole. Another is about the examples. In 1 mole of sodium atom is equivalent to 23 grams of sodium, and this is again equivalent to 6.022 times 10 raised to positive 23 atoms of sodium. Similarly, 1 mole of oxygen molecule is equivalent to 32 grams of oxygen, and this is equal to the Avogaro number times of molecules of oxygen. And in terms of the compound, 1 mole of sodium chloride is equal to the molecular mass of sodium chloride, and this is equal to the number of Avogaro units of the sodium chloride. And again, in terms of the carbon and in terms of the copper, 1 mole of carbon is equal to 12 grams. This is equivalent to the Avogaro number of a carbon atom, and 1 mole of copper is equal to its atomic mass. And this is again equivalent to the Avogaro number or atoms of the copper. This is one example. What will be if the mass of the atom is changed? For example, if the mass of the carbon is changed from 12 to 6 grams, its molecule or its mole becomes halved, and similarly the Avogaro number becomes halved. And in terms of the glucose, we can say like this. In the glucose, we do have 6 carbon atoms and 12 oxygen atoms and 12 hydrogen atoms and 6 oxygen atoms. Similarly, in terms of mole, we have 6 mole of carbon atoms, 12 mole of oxygen atoms, and 12 mole of hydrogen atoms and 6 mole of oxygen atoms. In terms of the Avogaro, we have 6 times the Avogaro number of carbon atom, 12 times the Avogaro number of hydrogen atom, and 6 times the Avogaro number of oxygen atom, and the like. This is one example of the concept of the mole. And what is the relationship between moles, number of Avogaro, and molar mass? Always remember, 1 mole is equal to this 6.022 or 23 times 10 raised to minus 10 raised to positive 23 Avogaro number. That is Avogaro number. So we can relate this in this way. The first one is the relationship between the number of mole and the Avogaro. In this case, we can say that, or we can use this relation to change the given mole into the number of particles. We can multiply the given mole by the Avogaro number, and to change the given amount of particles into the moles, we can divide the given particle or amount of particles by the number of Avogaros. Example, if you see this chemical reaction or this example, in this example, how many molecules are present in 1.75 mole of carbon dioxide? So we will follow 4 steps. The first step is state the given and the needed quantities. Then the given one is the amount of the mole of carbon dioxide is given, and we are asked to change this mole into the molecules of carbon dioxide. So connect this with the number of Avogadro. Step 2 is, the second step is write a plan to convert the moles to particles, and we have given mole of carbon dioxide, and then connect with the Avogadro number, and then change it into molecules of carbon dioxide. Step 3 is use the Avogaro numbers to write the conversion factor. In 1 mole of carbon dioxide, we have 6.022 times 10 raised to positive 23 molecules of carbon dioxide. So you can use this conversion factor, the Avogaro number over 1 mole of carbon dioxide, or 1 mole of carbon dioxide over Avogaro number molecules of the carbon dioxide. And finally, in step 4 is set up the problems to calculate the number of particles. So multiply the given mole of carbon dioxide by the Avogadro number, and we will have 1.05 times 10 raised to positive 24 molecules of carbon dioxide. This is one example how to convert the given mole into the amount of particles. Another example is, the second example is this one. How many moles are present in 1.20 times 10 raised to 25 silver atoms? So the answer will be, here the concept is the number of particles is given, and you are asked to change this number of particles into moles. So divide the given amount of particles by the Avogadro number in order to obtain the moles. Then divide this one by number of Avogadros. Finally, we will have 19.9 mole of silver. Another example is in terms of the molecule or formula, and it says that if the given number of nitrogen molecules is this amount particles, what is the mole of nitrogen, not N2 nitrogen atom? You are asked to change this amount of particles into the mole of nitrogen atom, not nitrogen molecule. This make it correction. This N2 to N. So the first one is, we have given the number of nitrogen molecules, and divide this by the number of Avogadro in order to obtain the mole of the nitrogen. So we have, and then again multiply the mole of nitrogen by its chemical formula, that is, in 1 mole of nitrogen molecule we have 2 mole of nitrogen atom. So 9.72 times 10 raised to 21 times, or divided by the number of Avogadro times 2 mole of nitrogen over 1 mole of nitrogen, we will have 3.23 times 10 raised to minus 2 mole of nitrogen atom. This is example how to convert mole into number of particles and number of particles into mole. Another is how to convert the number of entities into mass. And to do this, we will use this formula. The formula to convert the number of entities into mole is divide the number of atoms by Avogadro number and then multiply by its molecular mass. Example, in atomic level, and convert 3.22 times 10 raised to 20 atom of manganese to mass of the manganese. So we have given the number of atoms of manganese, and you are asked to change this into mass of manganese. What will you do is divide the number of atoms by number of Avogadro and then multiply by its molecular mass. When we divide the number of atoms by number of molecules and then multiply by the molecular mass of manganese, we will have this value, that is 2.94 times 10 raised to minus 2 gram. And in the formula level, convert 1.19 times 10 raised to 19 formula units of sodium fluoride into its mass. In similar way, divide the number of atoms by number of Avogadro and then multiply by formula mass, and the answer will be 8.7 3 times 10 raised to minus 4 sodium fluoride. This is another thing. Another one is how to change the mass to the number of entities or the number of particles. To do this, the formula will be first change the given mass into the mole by dividing by its molecular mass, and then multiply the obtained mass by the number of Avogaro, and you will obtain finally the number of atoms. For this example, let us see example. In atomic level, you are asked to do this. If a piece of copper weighs this amount, how many atoms does it contain? Then the solution: to do this, first convert the given mass into mole, and the mole will become 10 to the power of minus 2 mole, and then in 1 mole of copper contains 6.02 times 10 raised to positive 23 atoms. So if this amount is present in 1 mole, then how much amount of copper will be present in 10 to the power of minus 2 mole? The answer will be 6.02 times 10 raised to positive 21 atoms of copper. And another example is in terms of the formula level, and it says that nitrogen dioxide is a component of the urban smoke that forms from gases in car exhaust. How many molecules are present in this amount or this gram of nitrogen dioxide? The solution will be first change the given mass into mole, that is the mole is this amount, and then multiply this mole by the number of Avogaro. Finally we have 1.17 times 10 raised to 23 nitrogen dioxide molecule. This is the conversion of one component or one amount into another amount. Another thing is using chemical formula to write a conversion factor, and this can be again explained with examples. Example 1: calculate the moles of an element in a given compound. How many moles of carbon are present in 1.50 mole of aspirin? So we will follow 4 steps. The first step is state the given and the needed. We have this amount of aspirin, and we are asked to calculate the number of moles of carbon in the obtained existed in the aspirin. So connect with the subscripts in the formula. Step 2 is write a plan to convert the molecules of compound to formula 2 moles of an element. We have moles of the aspirin, and then use the subscript to change into moles of the carbon. Then interpretation is, from this we can say that in the aspirin, in terms of atoms in one molecule of the aspirin, we have 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms. In terms of mole, we have 9 mole of carbon, we have 8 mole of hydrogen, and 4 mole of oxygen atom. So we can use this. And step 3 is write the equalities and conversion factor using subscript. 1 mole of aspirin, in 1 mole of aspirin we do have 9 mole of the carbon, so we can use the conversion factor 9 mole of carbon over 1 mole of aspirin, or 1 mole of aspirin over 9 mole of carbon. This is not our aim. Our aim is, our focus is on the carbon. Step 4 is set up the problem to calculate the molecules of an element. So 1.50 times 10 mole of the aspirin times by the conversion factor, that is the number of mole of carbon, we will have 13.5 mole of the carbon. This is one example. Another example is, the second example is, let us see second example. Example 2. Calculate, it says, calculate the number of atoms of oxygen present in the 88 gram of carbon dioxide. What would be the mass of carbon monoxide having the same number of oxygen atoms, and the answer will be this one. For the first one, first change the given mass into mole, that is we have 2 mole of the 88 gram of carbon dioxide is equals to 2 mole of carbon dioxide. And in this case, in 1 mole of carbon dioxide we do have 2 moles of oxygen. If we have 2 moles of oxygen in 1 mole of carbon dioxide, and how many moles of oxygen will have in 2 moles of the carbon dioxide? So the answer will be 4 moles of oxygen. And to change this 4 mole of oxygen multiply by Avogadro number, we have 2.4092 times 10 raised to positive 24 oxygen atoms. For the second one, what would be the mass of the carbon monoxide having the same number of oxygen atoms? In 1 mole of oxygen atom is present in 1 mole of carbon dioxide, carbon monoxide. In 1 mole of carbon monoxide we have 1 mole of oxygen, and we have given 4 mole of oxygen atom in the carbon dioxide in the previous. So to have 4 mole of carbon monoxide, we have 4 mole of oxygen in 4 mole of carbon monoxide. So the molecular mass or the oxygen in gram is equals to, in 4 moles of carbon monoxide we have 4 times the mass of carbon plus the mass of oxygen, and this is 112 gram of the carbon dioxide, carbon monoxide will be present. Example 3 is about this one problem. Ammonium carbonate is a white solid that decomposes with warning. It has many uses, and it says finally how many formula units are in 41.6 gram of ammonium carbonate. B, how many oxygen atoms are present in this sample? And the solution for A is, first change the given mass into molecule, into the number of mole, and then multiply by the Avogadro number. Finally we will have the number of formula units of ammonia, and the molecular mass of the ammonia is 96. So when you change the mass of the ammonia into the number of moles, we have 0.4329 mole of ammonium bicarbonate, and then multiply this by the number of Avogadro. Finally we have 2.61 times 10 raised to 23 formula unit of ammonium bicarbonate. This is one way of calculating or relating the mole concept and the number of Avogadro. And this is all about today's lesson, and you will have some self-learning activities. And the first activity is this one, activity 1. This is the first activity for you, and the second activity is do this activity, and the third activity is this one. So try to do these activities by yourself. Thank you for watching today's video, and the coming video will be focused on the reaction stoichiometry relations, that is mole relation, mass relation, mole mass relation, and you will have finally the same self-test. Thank you. Bye bye. See you next time.